We're now going to take a look at an object-oriented case study of an image crawler. And we'll talk about how Java's object-oriented features are applied in this case study. And you can find this case study's source code at the link at the bottom of the slide, which is in the image counter project in the CS folder in my modern Java GitHub repository. CS stands for case study. And you'll see that what this case study does is it's going to crawl HTML pages recursively starting at some root, and then it'll count the number of images that are reachable from that root. So we'll give it a URI, and it'll crawl the pages and count the number of images that it finds there. We're going to start here in this first lesson by talking about the constructor for the image counter class and its mUnique IDs field. So this particular example is going to apply object-oriented features in Java to crawl the HTML pages recursively. And as you can see here, we're going to begin at some root URI, and then we're going to crawl the links recursively, counting as we go until either there are no more unvisited links to crawl based on the transitive closure of all the different links available on the web pages, or a max depth is exceeded. And so you'll see here, here's a very simple example we'll look at that's actually in the source code directory. And it shows how we can do this traversal, and we'll look at this in a second. The program is going to count the number of images that are available on each HTML page. And it's also, as we'll see, going to give us back some diagnostics if it runs into error conditions. For example, we want to make sure that each link is only counted once. So if there's cycles, for example, in our HTML file graph, then we want to ignore things that appear more than once. So we're going to make sure that each link is only counted once, and it'll also only be counted as long as the max depth is not exceeded. However, if there are redundant links and there are redundant paths, then they're going to be ignored. We're only going to count them once. And we're also going to ignore any links that are located past the max depth length. So you can see here that we're going to bound it for this particular example at a depth of 2. So anything that's below that will just be ignored. And of course, if you wanted to go further, you can raise the max depth when you run the program. Now, what's interesting about this program is the root folder can either reside locally, in other words, on the file system of the computer that's running the program, or it can be accessed remotely through the web. And in order to do this, we're going to leverage the JSoup open source HTML parsing library. So JSoup is a very cool library that does a lot of parsing for you, so you don't have a lot less work to do. It provides various APIs for fetching URLs, as well as extracting and manipulating data that you find on HTML pages. And it works both locally on your machine as well as remotely going across the network. Now, because of some limitations with JSoup, I defined a helper class, which I called JSouper just for kicks. And this makes web-based crawling and location file system or local file system crawling transparent. The program that I'm going to show you doesn't really care whether it's local or remote, in other words, local file system or web-based. It's going to have the same code. And then behind the scenes, this wrapper class will make that work. So let's start off here by talking about the image counter class and its constructor. So the heart of this HTML page crawler program is the image counter class. And you can see it's got about a little bit over a half dozen methods in it and got a field. These methods are actually going to be called recursively to traverse HTML pages from a given root. So let's start by taking a look at the image counter class and its field. This class, again, counts the number of images in a recursively defined folder structure that uses object-oriented programming features of Java to do the work. The field it has is called mUnique URIs. And we use this field to cache URIs that have already been processed to avoid visiting an HTML page more than once. And here's an example of why that could be a problem. Imagine we had some HTML file, and that HTML file might have duplicate links, or it could have multiple references to different other HTML files that existed in other links that are reachable from that file, and so on and so forth. So we want to make sure that we only count things once to make them unique. We use a hash set here to do this because it offers constant time performance for basic operations like adding in particular. And it works in good order as long as the hash function disperses the elements properly among the buckets in the hash table. And for our purposes, it's also been designed to work effectively for browsing through websites because it's got some clever strategies for being able to rearrange the implementation to go from a linked list to a tree, a balanced tree, when a lot of things hash to the same location. Because the crawler that we're writing here is single-threaded, we don't have to apply any complicated Java synchronizers or concurrent hash map or actually any synchronization whatsoever. There's only going to be one thread of control in this sequential implementation. So let's take a look at the image counter constructor. The first thing it does is it calls a method on an options class to get the root URI of the HTML page we want to begin our traversal. And this uses the good old singleton pattern from the Gang of Four book in order to be able to localize all the options processing. You may or may not be familiar with singleton, but you can read more about it at this link. The next thing it does is it starts counting the images at that root URI with an initial depth of 1, because that's where we're starting. And it's going to call count images, as we'll see when we look in part 2 of this case study. That will then recursively traverse through the structure of the directory, either remote or local, and it will return the total number of images. And then we go ahead and we print the total number of images that are reachable from that root URI. So for example, if we run this in the test cases that are provided with the project, it'll come back and say 21 total images are reachable from index.html. So that's the end of part 1 of our discussion of this Java object-oriented image crawler case study.